Hello everyone, my name is Mór Kapronczay and I would like to show you why we think Superlinked embeddings are great. In order to show you that, we are going to load the IBM employee dataset into our Streamlit app. That's a dataset downloadable from Kaggle. This dataset consists of rows that represent individual employees. We are going to use this data. More specifically, we are going to use two columns, education field and stock option level, where education field is a textual field with a limited set of textual values, while stock option level is a numerical field going from 0 to 3. So we are going to use a numerical and a textual field. After these columns are selected, we are going to create representations of this data two ways. Firstly, we are going to treat the whole data as it was text and embed it using some large language model. Quite common practice in the industry to just convert an entity to text and use an LLM embedding to represent the entity, hoping that the large language model's embedding can make some kind of magic and represent this complicated data in a useful way. While on the other hand, we are also going to create Superlinked embeddings, which is a more structured embedding method. You can observe the difference in dimensions that we are using the same large language model to embed education field, which is a textual field. We are also using 3 additional dimensions to embed stock option level, which is a numerical field. After we have created our embeddings two ways, we are going to create a pre-CA transformation of each. That is done in order to create a 2D representation of the embeddings so that we are able to visualize them. Let's do that and first create scatter plots by coloring the nodes based on their education field attribute. If you look at the LLM embeddings, the data is clustered around education field nicely. What's also important to see is that the clusters are two-dimensional, both principal components to encode information. So we can observe, for example, medical values in this 2D cluster here. On the other hand, Superlinked embeddings also cluster the data based on education field values. We can see medical values in this Y coordinate. And that is important because in this case, the second component, or the vertical axis, is used only to encode information in education field. So instead of having 2D clusters, we are having a one-dimensional cluster. And this will be important when we switch the plot to show coloring based on stock option level. So let's do that. Choose stock option level, create plots. The difference here is quite easy to see, as the LLM embeddings use both principal components to encode education field information. Points are totally randomly scattered around the space in terms of stock option level in case of the LLM embeddings. While in the case of the Superlinked embeddings, the other principal component, or the horizontal axis, is used to encode stock option level, and the points are totally ordered in terms of stock option level values as well. So as a takeaway of all of this, I could say that if you would like to create a vector search system that accurately represents information from different sources like text, numbers, timestamps, or categories, or any other signals, Superlinked gives you a better basis to do so.